Numbers are everywhere, shaping our understanding of the world around us. From the most basic counting to complex mathematical calculations, numbers form the foundation of our quantitative reasoning. In this exploration, we delve into the fascinating world of natural numbers and integers, unraveling their unique characteristics, differences, and real-life applications. Our journey begins with natural numbers, the building blocks of our numerical understanding, and progresses to integers, expanding our mathematical toolkit to encompass a broader range of values. Join us as we demystify these fundamental mathematical concepts. Imagine a child learning to count on their fingers, starting with 1 and progressing upwards. These counting numbers, 1, 2, 3, and so on, form the set of natural numbers. They are the numbers we instinctively use to quantify objects in the real world. Natural numbers are positive, whole numbers that extend infinitely in a positive direction. They are represented by the symbol n. The set of natural numbers is denoted as n equals 1, 2, 3, 4, and so on. The concept of zero marked a significant milestone in the history of mathematics. Zero, denoted by the symbol 0, represents the absence of quantity. When we incorporate 0 into the set of natural numbers, we arrive at a new set called whole numbers. Whole numbers include all natural numbers and 0. They are represented by the symbol W. The set of whole numbers is denoted as W equals 0, 1, 2, 3, 4, and so on. While natural numbers and whole numbers provide a framework for counting and representing quantities, they are limited in scope. They are insufficient for situations involving negative values, which are essential in various real-world contexts. Enter the realm of integers, a more comprehensive number system. Integers encompass all whole numbers, both positive and 0, along with their negative counterparts. This inclusion of negative numbers allows for a more complete understanding of mathematical concepts. Integers are represented by the symbol z, derived from the German word Zahlen, meaning numbers. The set of integers is denoted as z equals -3, -2, -1, -2, -1, 0, 1, 2, 3, and so on. This sequence continues infinitely in both directions. 0 acts as the central point, separating positive integers from their negative counterparts. Each integer has a unique position on the number line. This expansion into negative values allows us to express concepts like depths, temperatures below 0, and even elevations below sea level. Integers also help in understanding distances in opposite directions, such as east and west or north and south. They provide a complete picture of the numerical world, enabling us to solve complex problems and understand the universe better. Section 5. Unraveling the differences, natural numbers versus integers. The key difference between natural numbers and integers lies in their scope. Natural numbers are strictly positive whole numbers used for counting. Integers, on the other hand, encompass a broader spectrum of values, including positive and negative whole numbers, as well as 0. While all natural numbers are integers, not all integers are natural numbers. For example, -5 is an integer, but not a natural number. This distinction is crucial in various mathematical operations. Section 6. Navigating the labyrinth, whole numbers and their ambiguous definitions. The term whole numbers often leads to confusion due to varying definitions. Some mathematicians consider whole numbers synonymous with integers, including negative numbers. Others define whole numbers as non-negative integers, excluding negative values. To avoid ambiguity, it is always best to specify whether whole numbers refer to all integers or only non-negative integers. The term integers itself provides a clear and unambiguous representation of this set of numbers. Section 7. Examples of natural numbers, whole numbers, and integers in action. Let's solidify our understanding with some relatable examples. Numbers are all around us, and they play a crucial role in our daily lives. From counting objects to measuring temperatures, numbers help us make sense of the world. Natural numbers, the number of students in a classroom, 25. Natural numbers are the simplest form of numbers we use for counting. They start from 1 and go on infinitely. For instance, when a teacher counts the students in a classroom, they might find there are 25 students present. The number of books on a shelf, 12. Similarly, if you were to count the number of books on a shelf, you might find there are 12 books. These are all natural numbers because they are positive and used for counting. The number of apples in a basket, 7. Imagine you have a basket filled with apples. Counting them, you find there are 7 apples. This is another example of natural numbers in action. Whole numbers. The number of goals scored in a soccer match, 3. Whole numbers include all natural numbers and 0. For example, in a soccer match, the number of goals scored might be 3. This is a whole number because it includes 0 and all positive numbers. The age of a person in years, 30. When you ask someone their age, they might say they are 30 years old. This is another example of a whole number, as age is always a non-negative number. The number of days in a week, 7. The number of days in a week is 7, which is a whole number. Whole numbers are used in various contexts, including timekeeping and scheduling. Integers, the temperature outside on a winter day, -5 degrees Celsius. Integers include all whole numbers and their negative counterparts. For instance, on a cold winter day, the temperature might drop to -5 degrees Celsius. This is an example of a negative integer. The balance in a bank account after a withdrawal, -$50. If you withdraw money from your bank account and it goes into the negative, you might have a balance of -$50. This is another example of an integer, as it includes negative values. The altitude of a location below sea level, -100 meters. Some places on Earth are below sea level. For example, the altitude of a location might be -100 meters. This is a negative integer, showing how integers can represent real-world situations. These examples demonstrate the practical applications of natural numbers, whole numbers, and integers in various contexts. Whether it's counting objects, measuring temperatures, or managing finances, numbers are an integral part of our lives. Understanding these different types of numbers helps us navigate and make sense of the world around us. Section 8. Integers and natural numbers in everyday life. Integers and natural numbers are indispensable tools in our daily lives. From the moment we wake up to the time we go to bed, we encounter these numbers in various forms. Whether it's setting an alarm clock, checking the time, or even counting the number of steps we take in a day, integers and natural numbers are always at play. We use them for various purposes, including counting and measuring. Counting objects, measuring distances, tracking time, and even in educational settings where children learn basic arithmetic. These numbers form the foundation of our understanding of the world around us. Quantifying ingredients in recipes all rely on natural numbers and integers. Imagine a chef meticulously measuring out ingredients to create a perfect dish. Each measurement, whether in grams, liters, or cups, is an application of these fundamental numbers. Financial transactions, bank balances, deposits, withdrawals, debts, and credits are all represented using integers. When we check our bank balance, make a deposit, or withdraw money, we are engaging with integers. These numbers help us manage our finances, ensuring that we can keep track of our earnings and expenditures. Temperature measurement temperatures above and below 0 are expressed using integers. This allows us to understand the weather and prepare accordingly. Whether it's dressing warmly for a cold day or staying cool during a heat wave, integers help us navigate the changing climate. Sports and games scores, points, rankings, and statistics in various sports and games utilize integers to track progress and determine outcomes. From the scoreboards in a basketball game to the rankings in a tennis match, integers are essential in keeping the competitive spirit alive. In sports, every point scored, every goal achieved, and every record broken is quantified using integers. These numbers not only track progress but also add excitement and thrill to the games we love to watch and play. The pervasive use of integers and natural numbers highlights their significance in our quantitative understanding of the world. From business analytics to classroom learning, these numbers are integral to our daily lives, helping us make sense of data, solve problems, and make informed decisions. Section 9. Conclusion. Appreciating the significance of number systems. Natural numbers and integers are fundamental building blocks in the vast and intricate world of mathematics. Understanding their properties, differences, and applications is crucial for developing a strong foundation in mathematical reasoning. As we continue our mathematical journey, we encounter increasingly complex number systems, each building upon the foundations laid by natural numbers and integers. Appreciating the elegance and significance of these fundamental number systems empowers us to navigate the fascinating world of mathematics with greater confidence and understanding.